Welcome to class session 3. Let's go ahead and take a look at what we're going to do this week. We're going to go over your assignments that are due, new assignments, new topic, and that's it. That'll be the end of today's lesson. So the first thing is your assignments due. This should have already been turned in, but I'm just reviewing this for you. Chapter 2 of Hudson and Miller's, the reading and the quiz needed to be completed, skimming Ashlock's text, submitting notes on your students, and then doing the discussion board activities, the error analysis of whole numbers, and the Dos Rios Virtual School District activity. Your new assignments this week are to complete Chapter 3 in Hudson and Miller and take the reading quiz on this chapter, and then begin skimming Section 2 in Hudson and Miller starting on page 163. Just a heads up, you will be taking a quiz later on about Section 2 once you have read the entire section. Begin lesson planning for your math project, and then do a discussion board for error analysis of fractions and decimals. And I'm giving you more of an idea of fractions as we go on to the new topic. So just to kind of keep you in mind, I'm giving you some strategies to help with this discussion board this week. Additional tasks. This is an additional task, but it is not required to do it. It is just to your benefit. As in the syllabus, I've asked you to look at your students that you're working with throughout the semester for your math project and even your written expression project. And please share with me if you have any questions about the students, if there's anything that I can help you with, if there is anything that I can help you improve your instruction for your lesson plans, etc. Do not hesitate to email or call me as you begin starting your lesson planning process for your students. And this also reminds me that I need to tell you what your new password is for this session, and it's the word mathematics. Please send that to me after viewing this video. Okay, let's go ahead and dive into our new topic this week, which is modifying instructional plans, and we're going to look at this specifically in the area of math for understanding conceptual knowledge, declarative knowledge, and procedural knowledge, and applying the different types of knowledge to give you examples of what that looks like. And then after I give you an example, we're going to break down a standard as it is written and come up with ways that we can really modify instruction for a student who's struggling with a specific skill. So real quick, I'm going to just review again what conceptual understanding, declarative knowledge, and procedural knowledge looks like. Let's start with conceptual knowledge. It's a primary goal of mathematics instruction when students understand the concepts underlying various types of mathematic knowledge and skills, their depth and understanding is enhanced, and it is more likely that students can generalize the concept and skills to apply to real life. Ideally, these concepts are going to be introduced when it's a new topic or skill. Then going on to declarative knowledge. This type of knowledge involves memorization and automaticity in areas such as number recognition, counting, recall of basic facts, reading and writing fractions, telling time, and many other mathematical tasks. Then procedural knowledge refers to mathematical tasks that require the student to follow a series of sequential steps in order to solve a problem. It's commonly taught to help students solve computation problems or word problems. So in going back to relate to fractions, our goal is for them to understand the concept of fractions, meaning whole to part and part to whole. Going on to the declarative, it's being able to read and write a fraction. So for example, you can see a picture of 1/3 and a student can say it's 1/3, or coloring a picture to see what is 1/3 of a rectangle, those type of things. And then moving on to procedural, it's being able to actually compute fractions and to deal with word problems. So I'm going to give you some examples that are visual about. Here's a conceptual type of question that would be asked. I'm tiling a floor. So far, I've tiled the shaded part of a floor diagram below. What fraction of the floor has been tiled? That's very conceptual. How many holes to the part? Or I'm sorry, the parts to the whole. And understanding that concept. Here's an example of procedural knowledge when it comes to computation, having a problem and trying to solve it. Here's another type of procedural question. Jenny had a pizza that was divided into 8 equal slices. She ate 3 of them. Danny has a pizza that is the same size, but his is divided into 4 equal slices. He ate 3 slices of his pizza. Who ate more pizza? There's a lot of steps to figuring out the difference between the two and then to answer a question. Here's an example of declarative knowledge where a student would color 3 parts red, 4 parts blue, 1 part green, and then answer what fraction of the circle is red by reading the graph or the little chart. They can answer that quickly. What fraction of the circle is blue? Once again, the automaticity of knowing how much of the circle is blue, and what fraction is green in this type of a setting. This is also considered to be more of a word procedural knowledge as well, but it's really the basic recall of those facts and having the automaticity to see it real quick and then recognizing what the answer is. You might be thinking why I'm sharing fractions with you, but just to let you know, fractions without a doubt the most problematic area in mathematics education according to Lean Streflin. And also I'm going to share with you some statistics. Only 65% of 8th graders in 1996 and 73% in 2005 could correctly shade in a third of a rectangle. In 2003, only 55% of 8th graders could correctly solve a word problem that asked how many pieces, each an eighth of a yard long, could be made from a piece of string 3/4 of a yard long. It's really knowing kind of where the basic begins, and that came from an AEP, just to let you know. But it's very important to know that students struggle with this, and I'm giving you a skill and a standard that starts with 3rd grade, but just take a moment to realize that these 8th graders are still struggling with a concept that was taught to them in 3rd grade. And real quick, before we take a moment to look at the standard, I also want to just point out, to answer this question, what is the nature of the mathematics curriculum? Please know that when you review standards, the nature of mathematics is included right within the standard that you can find at the very end of it, and it says exactly what it is. So for this skill that we're going to talk about, mathematicians use numbers like writers use letters to express idea, and that's the nature of what we're trying to get across to our students. In looking at this, I've kind of color-coded things for you. Everything that is yellow is the conceptual understanding, everything that is green is declarative, and blue is procedural. Let's go ahead and take a look at the skill real quick. The whole number system describes place value relationships from ones to 10,000s and forms the foundation for efficient algorithms. And so we want students to be able to read and write these numbers, of course, and we want them to compose and decompose multi-digit numbers based on place value, kind of organizing them and telling them what the number is based off of how much it is. So how can we modify this for our students? Well, let's take the standard and topic and modify it. Where do we start? Well, the first thing, as always, we need to get a baseline. So we need to assess the student to see where their current skill level is. And if we have a little 3rd grader who is supposed to live up to this standard but doesn't even know what a 1 or 10s is, then we need to go back to the very basics and then build up to 10,000. So just one way of modifying it is just chunking it into smaller components and doing more direct instruction in smaller chunks. So modifying it that way is a great way to at least get started. Then we're going to go from there and help them to understand how to read and then write, and kind of teach those kind of hand in hand of looking at something in the way it's written and then showing a picture of it. Then, to even go a little bit further for an additional instructional strategy, we can make a real-world application out of it by giving them sorting activities. So we can have students put years on a timeline, basically putting them in order by knowing that place value, knowing what's the smallest to what's the largest. Also, bringing out items from your classroom, put a price tag on it, say a pencil's worth this much, a eraser's worth this much, hand sanitizer's worth this much, etc., without decimals, of course, because you're just wanting them to understand the concept, and have them place the items in order based off of how much they cost. Both of those are great real-world applications of knowledge of how little or how big something is based off of place value, which is the whole concept of what we're trying to get across. Of course, use manipulatives. I'm a very big proponent on visual aids, tactile aids, and then keep in mind your intelligences. So if you have a kid who's a kinesthetic learner, you might want to go out on the playground and draw this chart and have them physically put rocks in the different areas, or have them put boxes or balls from the gym or whatever it may be to get them physically moving things in and out to understand. Or you can even just have your cubes like this, your Unifix cubes or your other manipulatives that you have in your classroom, and have them physically go outside and put these in their place. Or even having them just draw with sidewalk chalk is a great idea as well. Or if they're musically inclined, have them learn the standout math chants for place value, such as hundredths, tenths, decimal point, ones, tens, hundreds, thousands, 10,000s, etc. That's how the little chant goes. Place value boards are great. Counting manipulatives charts, having them understand the difference between how, if you had the number 356, I need 3 of these, 5 of these, and 6 of these. And online tools are really great for them to physically manipulate with a mouse. How to create a number and then how to break a number apart is really great as well. That brings us to the end of today's lesson. So if you have any questions or final thoughts about this topic, let me know. I hope this gives you a great understanding of kind of how to take those different levels of conceptual, declarative, and procedural knowledge to get concepts taught. Thanks.